So let's talk about this one. This one is worth going through. I think last time we talked about sorting handwritten digits into categories of 0 through 9. And here we're going to use images. So here in Google Colab, I'm just going to make a new notebook. And all right, so this is the Fashion MNIST images, which are a bunch of little pictures of different clothing items. And they get sorted into these categories: t-shirt and dress and coat and sneaker and ankle boot and so on. So each image is 784 values, which are the brightness of the pixels going from 0 to 255. So that's the X value. 784 numbers come in, and then it's going to pass through a neural network and put it in outputs. So here's what we're going to plan. Here's the input image, turns into 784 pixels. Then it's going to have hidden neurons here that do a bunch of work, and then output neurons. There are going to be 10 of these, sorting it, which is going to be a signal saying the probability that it is each of these things. And all right, that's the game. We're going to use 128 hidden neurons and linear calculations throughout. So this will train the neural network. So we put that in. This is just going to make it bigger. This is going to import TensorFlow. It's going to break it into training images and training labels, test images, and test labels, loading the data. Then it's going to normalize it, dividing it by 255. So instead of the signals going from 0 to 255, they'll go from 0 to 1. This is normalization, and then for both the training and the test images. And then it's going to do a model. And here's where the input comes in, 28 by 28 pixels. Here's the hidden layer, 128 neurons. And here's the output layer, 10 neurons. And that's it. You just compile it and then fit. And this is taking default settings for how to fit. So I'm not even quite sure exactly which fitting procedure it's using here or anything. We can probably find out by interrogating the model, and might tell us in the book. But anyway, the point here is just sort of awareness to see how it works. Here it is downloading data. TensorFlow provides the standard data to practice with. Now it's training. Epoch 1 of 5, so it's going to use some kind of gradient descent here, where it's having a series of epochs. And here's the loss. So the loss was 0.50, and then it goes to the next step. And the loss is now down to 0.37, so it's descending, what you expect, and it's taking it like something like 7 or 10 seconds to calculate each cycle. And you see the loss is in fact going down every time. All right, and it's after 5, the loss has gotten down to here. Here's the accuracy on the training set. It's gone from 82% up to 89%. So that's the result of that, and it should have also given us, thought I should also have seen evaluate on the test labels. Maybe I didn't get that last line in my code. No, evaluate, it's still doing the fit. Okay, it's still doing this. All right. It's not done fitting yet. See, the green bar tells me it's still running. Okay, so the accuracy on the training set got down to 89%. Okay, here we go. So I guess it was, here's the test set. Okay, so all right, so this is the accuracy on the training set, and this is the test set. So it's 89% accurate on the training set, but only 87% on the test set, which is reasonable. And notice, by the way, what we did here, I think, was the simple model where you stop when it gets worse. It was low accuracy, the accuracy keeps getting better every time. All right, so just did it 5 cycles. Okay, so now you can view the results for 20 images and see how they work. I want to add a block of code. Here we go. All right. And now this shows the probability. So here, for example, is one that really is a 1. This is category 0, category 1, and as you see, it's 99% chance of category 1. So that worked. Here's 97, here's 97. So those work fine. But we'll find ones it got wrong here. Like here, it was category 6, 0, 1, 2, 3, 4, 5, 6. So it got it right, but it had some confusion. If I just look for small numbers, here's this one it got wrong. It was category 4, 0, 1, 2, 3, 4. It gave it only 26% chance of category 4 and decided it was probably a category 2. So this one, it got wrong. And there are probably others that it got wrong. So you can see, and then you can go look at the ones that it actually did get wrong. And so this one here was from 0 to 19. So 19, 18, number 17 it got wrong. So I want to print out the results for number 17. So I'm going to do this. And instead of doing 11, like I did there, I'm going to do 17 because in my case it was 17 that came out wrong. So let's make this image 17. And if I figured it all out right, then we'll have the first one, which is one it got right, number 0. And this, holy cow, it got that wrong. Boy, I can see why that doesn't look like anything to me. And so it couldn't tell if that was a category 2 or a category 4. And category 2 is pullover, and category 4 is coach. And I must say, I don't even know what the difference is much between a pullover and a coach, so I don't blame the model for not knowing either whether that's a pullover or a coach. All right, so it's understandable how it would get that wrong. All right. And you can train it for more epochs, and if you do that, you'll be overfitting. You watch the accuracy for the training set will go up to 94%, but the test set doesn't really go up much at all, so the additional training doesn't really improve your model any. And then you can do find a flag here. So that's all I wanted to show you about that one, but it's kind of nice to see it do realistic images. So stop.